All right, what did we write down yesterday as the formula for how to find the measure of each interior angle? Yes, n minus 2 times 180 degrees, and then we divide that by n. So we want to find the measure of each interior angle for an octagon. How many sides does an octagon have? How many sides does an octagon have? 8, thank you. So n is 8. So substituting into our formula, we have 8 minus 2 times 180 degrees divided by 8. And what would that give us? Well, 6 times 180 divided by 8. After you divide it by 8? Yep, what does it give you for your final answer? 135, thank you. You were going step by step, which I normally do, so I apologize for not being clear. 135 degrees. Number 5, we're doing the exact same thing. It says beekeeping involves raising honeybees for their honey. Bees construct combs consisting of cells in the shape of a regular hexagon. How many sides does a hexagon have? 6. So sketching this out real quick, it says at what interior angle do 2 sides of a cell meet? So here's my best attempt at a regular hexagon. Where 2 sides meet would be like right here. That is an interior angle. Interior angle is where any 2 sides of a convex polygon meet together. So we're going to do 6 minus 2 times 180 degrees divided by 6. What do we get when we finish doing that subtraction, then multiplication, then division? 120 degrees, absolutely correct. Very, very nice work. All right. So today we're going to finish up our composite area work in your notes. That will leave us with one thing left to finish up, and we should finish up by the end of class tomorrow, possibly going right into the very beginning of class on Thursday. But we're going to just focus on composite area today. We're going to do most of the problems on page 7. There's going to be one that we will probably skip for time. We're going to walk through at least 5 of the problems on this page. So let's look at part C. We want to find the area of the shaded region, so everything here in pink. When I'm looking at that pink figure, let's pretend for just a minute that there was not this triangle-shaped hole in the center of it. How would I go about finding the area of that pink figure? Do I have a formula that works for the shape that I'm looking at, or do I need to break it into smaller shapes? Break it into smaller shapes. What kind of shapes would we break it into? Rectangles. We can cut it here and make this top rectangle and the bottom rectangle. Or we could cut it here and have a left rectangle and a right rectangle. Do you guys want to do top and bottom or left and right? It doesn't matter where we cut this. Left and right. Sounds good. Okay, so I'm going to need to take the area of one rectangle and add it to the area of another rectangle. And then what shape is the hole that we need to remove? A triangle. So we're going to subtract the area of a triangle. So I'm going to call this rectangle 1 and rectangle 2 so I don't get them confused. We're going to call this one here rectangle 1. I'm going to call the one over here rectangle 2. How do we find the area of rectangles? Length times width. So for rectangle 1, we're going to do length times width. What is the length of rectangle 1? Or the width, either one. 7 is one of the measurements. And 9, tell me how you got 9 for the other one. Yep, we have 7 and 2. Those are our vertical distances that are stacked on top of each other. So this side over here would be 9 meters. So 7 and 9 for my length and my width on rectangle 1. What is 7 times 9? 63. So we have 63 meters squared for rectangle 1. Now we need to find the area of rectangle 2, the smaller one, the one on the right. What is the length and the width for rectangle 2? 7 and 4. 7 for the length this time this way, and then 4 this direction. So 7 times 4. What is 7 times 4? 28. So 28 meters squared. And then we need to find the area of the triangle so that we can remove that. How do we find the area of a triangle? 1/2 times base times height, yes. And what kind of relationship do the base and the height have to each other? Has to be a right angle. They have to be perpendicular to each other. Do I have the base and the height of this triangle? I have the height, 6 meters. This does look like it's a right angle here, so we're going to go ahead and assume that. We're not normally allowed to assume right angles, but on pictures like these, I think we're okay on that one. So 1/2 times whatever the base is, times that height of 6. So now I just need this length here. Do I have the ability to find that? How can I do that? Add 5 and 4 and subtract that from 11. So we're going to do 11 minus 5 plus 4. 5 plus 4 is what? 9. And 11 minus 9 gives me 2. So this distance right here is 2 meters. So there's my base. What is 1/2 times 2 times 6? 6. We have 6 meters squared. All right, we are ready to find our composite area, the area of rectangle 1 plus the area of rectangle 2 minus the area of the triangle would be 63 plus 28 minus 6. So what do we get for our composite area? Yep, 85. What kind of units? Meters squared. Nicely done. What kind of shapes do we have going on in part D? Yep, a circle and a square. Which one's bigger? Which one is bigger, the circle or the square? The square is the larger figure. It is on the outside of the circle, so it is larger. So we're going to need to do the area of the square minus the area of the circle. How do we find the area of squares? Side length squared. What is the measure of the side of our square? 12. And you guys see this little mark right here next to the 12? Looks kind of like an apostrophe. Does anybody remember what unit that is? That is feet. If it has 2 little marks, it's inches. If it has 1 little mark, it's feet. And the only way I was ever able to remember this, and I still have to do it, do you guys remember in elementary school clapping out syllables for words? Feet has 1 syllable. It's 1 mark. Inches has 2 syllables, so it gets 2 marks. That is the only way I've ever been able to remember that. So we have 12 feet for the side length of our square. So we're going to do 12 squared. What is 12 squared? 144. So we have 144 feet. And then we need the area of our circle. We wrote this down a couple places yesterday. How do we find the area of a circle? Yep, pi times the radius squared, pi r squared. Do we have the radius in this picture? No. Where does the radius go? Like, if I saw it drawn in a picture, what would I need to see visually to know, aha, that's a radius? Has to go from the center of the circle, and then it has to go where? Line over to the edge. So like this, or it could come up here, or it could go up like this. No matter which way we draw it, it has to go from the center to the edge of the circle. So here's a radius. And what do you notice about that radius in relationship to the square? How much of the side length of the square is that radius? It's half of it. Well, what's half of 12? 6. So this is 6 feet. So the area of my circle is pi times 6 squared. Now, if you're using one of my yellow calculators and you put it in just like that, we push the pi button. Remember, don't use 3.14. Use the pi button so that it's more exact. Pi and then parentheses, 6 parentheses, and hit squared. When you hit enter, what kind of thing does it show you on the screen? Does it give you a decimal answer? Shows 36 pi. How do you make it show you the decimal answer if it shows you something like 36 with the pi still in it? The arrow's right above. So what is the area of this circle? 113.097, and that would be feet. So now to find our area, we're going to do the area of the square minus the area of the circle. So I have 144 minus 113.097. And that gives us what? $30.903. And that would be feet squared. I forgot my squareds up here on these guys. Sorry about that. Anytime we're finding area, it's going to be units squared. All right. So far, so good? Let's look at part C then. What kind of shapes do we have going on in part C? What's the big outside shape here? That's a trapezoid. So we need the area of the trapezoid. And then we're going to minus the area of this hole. Is this a shape that we just have the name of? No. Can I break it into shapes that I know the names of? How many shapes would I have to break it into? 2. And what would those 2 shapes be? Yep, probably rectangles. I might be able to get a square out of it depending on like the way I break it up and what that makes the sides, but I think it's going to be 2 rectangles. So I'm going to have to put those 2 rectangles together. So once again, I'm going to call them rectangle 1 and rectangle 2. I will add those 2 areas together because that will give me the whole area of the hole. And then I will minus that from the area of my trapezoid. So let's find the area of the trapezoid first. To find the area of the trapezoid, what is our formula? Absolutely correct. 1/2 times the height times base 1 plus base 2. What is the height of this trapezoid? 10. Right here. I know it's the height because it's making a right angle with my bases. So here's my height. So that's what I'm going to put right after the 1/2. And then how big are my bases? 12 and 16. So we're going to add the 12 and 16 together. So what is 1/2 times 10 times 12 plus 16? Remember, you have to add the 12 and the 16 either in parentheses or you have to add them together before you times them to the 1/2 and the 10. 140. Do we need units with that? Why or why not? They didn't give us any units. So I can just leave it as 140, or if I really wanted to, I could write units squared so that I'm really clear. But if there are no units given and so you don't put units on it, that's going to be totally fine. You don't, no, you wouldn't put a squared on the 140. It would be the units part that would be squared. So if we don't have units, we won't put that on there. Good question. Very good question. Could you do a U and then squared? Yes, that would be fine. Absolutely. All right, so now we need to find the area of our two rectangles. So we need to decide which one is rectangle 1 and which one is rectangle 2. We can split it horizontally like this, so that I have a top and a bottom rectangle. Or I can split it vertically like this, so that I have a left and a right rectangle. Do you guys want to go horizontally or vertically? Vertically, that works for me. We're going to get the same answer either way. So let's call this one over here rectangle 1, and this one over here rectangle 2. I need length times width for both of them, so let's look at rectangle 1. What is my length and what is my width on rectangle 1? This guy right here. There. 9 and 4. How did we get 9? Yep. We've got this bottom one, what we're calling rectangle 2. That has a height or a width or length or whatever you want to call it of 3 in a vertical distance here. And then from the top of rectangle 2 up to the top of rectangle 1, that's an additional 6 units. So that means this side over here has a measurement of 9. And what did you say the other measurement was? 4. Right here they tell me that the width or the length, depending on which you call it, is 4. And then what is 9 times 4? 36. So 36, since I did U squared on the other one, I'm going to do U squared on this one. And then for rectangle 2, I need length and width. 4 and 3, yes. And 4 times 3 gives me what? 12. So I have 12 units squared. All right, so now we need to do area of the trapezoid minus the area of my 2 rectangles put together. So I'm going to have 140 minus, and then inside the parentheses I have 36 plus 12. What is 36 plus 12? 48. So I have 140 minus 48, which would give me what? 92 units squared. Very nice work so far. Yes. All right, let's see what you got. You cut it this way? That'd be 24 and then 3 times 8. So this would be 8 right here for the other one. So you'd have 3 times 8 times rectangle 2. Yep. So that should fix your problem. You should end up with the same answer then. All right, there's 2 more problems that I'm wanting to do. I want to do F and then I want to do H. We're going to skip part G. What kind of shapes do we have going on in F? Hexagon and a rectangle. Which one is the whole? The rectangle. So we need to do the area of the hexagon minus the area of the rectangle. What do we know about the hexagon? One side length is 22, and we're assuming that this is a regular hexagon. So that means all of our sides around here are going to be a length of 22. How do we find the area for a regular hexagon or a regular pentagon or a regular octagon? 1/2 times apothem times perimeter. Do I have the ability to find either of those fairly easily? The apothem or the perimeter? Which one would be easier to find? Perimeter. How do we find the perimeter of this regular hexagon? Number of sides times the side length. How many sides do we have? 6, and each side length is 22. What is 6 times 22? How much? 132, thank you. All right, so I'm going to look at my formula here. 1/2. I don't know the size of the apothem yet, so I'm going to leave some space. But we do know that the perimeter is 132. All right, so now we're going to find the apothem. So the first thing I need to do is find the center of the hexagon, like right here. And we're going to draw 2 line segments that are radii. So they go from the center to a corner, center to a vertex. I'm going to go ahead and draw it this way so that I don't run into that hole, and hopefully I don't get too confused with my picture. So now we're going to find the measurement of this angle right here. It's called a central angle. How do we find the measurement of the central angle for a regular polygon? Yes, 360 divided by however many sides we have. What is 360 divided by 6? 60. So this central angle has a measurement of 60 degrees. And now we're going to draw in the apothem, the thing that we really want to find here. So the apothem goes from the vertex to the, sorry, not the vertex, from the center to the side, and it makes a right angle where it hits the side. So we are going to find, using this right triangle right here, the apothem of this hexagon. All right, so I'm going to redraw that little yellow shaded triangle here off to the side. So here's my apothem. It's making a right angle with half of the side of my hexagon. And then we have this radius right here. What is the apothem doing to this central angle? Cutting it in half. Well, what's half of 60? 30 degrees. So that angle on my right triangle is a 30-degree angle. I know that this entire side of the hexagon is 22. So how big is this little part? 11. This would be the same size as this. This is 11. This one is 11. And we're wanting to use this information to find the apothem. So I'm going to stand at the angle that we know, this 30-degree angle here. I'm going to label my sides, hypotenuse, opposite, adjacent. Which color is the hypotenuse in this picture? This one right here. Which one is my hypotenuse? Which color? The orange one, because that's opposite my right angle. So here's my hypotenuse. Is the 11 or is the apothem my opposite side? 11 is my opposite side, because I would have to go through the triangle from this angle to get to the side that is 11. If I have to go through the triangle to get there, it's my opposite side. So that means the apothem is my adjacent side. All right, so ka COA. We're wanting to find the apothem, which coincidentally is my adjacent side. So A and A helps me keep them together. And then what's the side that I know, hypotenuse or opposite? Opposite. Which one of these trigonometric functions will let me use the adjacent and the opposite sides? Tangent. So we're going to use our tangent function. Let me scoot all of this down just a little bit so that I have plenty of room to do that. So we're going to have tangent of my angle, which is 30 degrees, is equal to the opposite side, which is 11, over my apothem, which I'm going to use an A. Stands for adjacent or apothem. Either way, it's the thing I'm finding. How do I get the A out of the denominator? Multiply. We're going to multiply both sides by A because it is the denominator. It's going to cancel my denominator out over there on the right. So I have A times the tangent of 30 degrees is equal to 11. And now what do I need to do to get the A all by itself? Divide. We're going to divide both sides by the tangent of 30 degrees. And now I would need to grab my calculator. 11 divided by the tangent of 30 degrees. $19.052. What's the fourth number there? 5. What is this 5 right here going to do to the 2 that's right in front of it? It's going to round it up. So 19.053 is what we're going to use for our apothem. So what is the area of my hexagon then? 1/2 times 19.053 times 132. One half times 19.053 times 132. 0.498, absolutely. They don't give us units on this, so we're going to go with units squared again. All right, so there's my area of my hexagon. We need to have the area of the rectangle as the whole that we're going to take out. Rectangle is length times width. What are the length and the width of this rectangle? 18 and 22. So we're going to times 18 and 22 together. What is 18 times 22? 396. All right, let's put this together then. The area of the hexagon minus the area of the rectangle is going to be 1257.498 minus 396. What do we get when we subtract those? 861.498 units squared. All right, one last problem that I want to touch on. We're going to skip G and just do H. What kind of shapes do we have in part H? A circle and a triangle, absolutely. Which one's bigger? Circle. So we're going to do the area of the circle, the bigger shape, minus the area of the triangle. How do we find area of circles again? Pi r squared. And what is the radius of this circle? 6. So pi times 6 squared. I feel like we did one just like this earlier. A circle that had a radius of 6. We did. So what did we get when we did pi times 6 squared? 113.097, and that's going to get the units of centimeters squared with it. Then we need the area of our triangle. How do we find the area of a triangle? 1/2 times base times height. So 1/2. The only thing that I have to work with is this right here. How big would it be right here? That'd be another 6 centimeters. So how big is this whole side? 12 centimeters. There's my base. This would be my height. Makes a right angle here. Goes from the center to the edge. So this dashed line would be what part of the circle? Be a radius. Well, how big are all the radii in this circle? 6. So 1/2 times 12 times 6. 36. 36 centimeters squared. I need you to put that away, please. So the area of the circle minus the area of the triangle is 113.097 minus 36. What do we get when we subtract those? 77.097 units with that. Centimeters squared. Very nice work. Anytime we are looking at a regular polygon, a pentagon, a hexagon, an octagon, a nonagon, a decagon, any of those, if we need a side length, if we need the apothem, we're going to have to use that right triangle trigonometry, SOHCAHTOA, in order to find that. If I had known only the apothem on this problem here with part F, if I had only known the apothem, then I would have had a value here for the adjacent side, and I could use that to find the opposite side. Same idea as what we did in this problem, except the pieces that I know and the piece that I'm looking for would be reversed. So I would still choose tangent because I would still want opposite and have adjacent. So I can still use my right triangle trigonometry in order to find those pieces. There is one on the homework where you have the apothem and you don't have the side length, and it asks you to find the area. That's why I wanted to talk about that particular piece. If you guys have any questions about the homework, we've got a couple of minutes for you to look at it and ask any questions that you might have. Homework is due tomorrow.